So what is meant by the functional isomerism means compounds are having same molecular formula but differ in their functional group is called as a functional isomerism. Okay, and here I gave already one example. So what is the example I had given means carboxylic acids are converted into the esters. Okay, carboxylic acids are converted into ester. This we can call as a carboxylic acid. And what is the molecular formula of this one means here C3. So what is the molecular formula of this one here? C3. Total how many hydrogens are there? H6O2. So in this also we are having 3 carbon atoms, 6 hydrogens and 2 oxygens. Both are having same molecular formula but differ in their functional group. First one is having the carboxylic acid functional group. Second one is having the ester functional group. Okay, so carboxylic acids are converted into the ester. Okay, acids and esters are we can consider as a functional isomers. Okay, acids and esters are we consider as a functional isomers. What is another example means here? Cyanides. Methyl cyanide CH3 bond CN. Okay, so this we can call as a cyanides. Cyanides and isocyanides. Cyanides and isocyanides. What is the functional group of the isocyanide means CH3 bond NC. So this we can call as a methyl isocyanide. Methyl isocyanide. So these two also we can consider as a functional isomers. Okay. Next, so we have some other examples also. What are the other examples we are having means here? One is carboxylic acids, sorry, alcohols, aldehydes. Before that, here aldehydes we can take. Aldehyde means how we can write as here CH3 bond CH2 bond CHO. Anyone who can tell me what is the IUPAC name of the given compound? What is the IUPAC name of the given compound? CH3 bond, C double bond O bond CH3.
Propanol.
Yakshit Aditi Samhita. Okay. Right, ma. So what is the IUPAC name of the given compound, ma?
Propanol.
Very good, ma. Samhita is propanol. So what is the IUPAC name of the given name is here? Propanol. Okay. Propanol. Samhita, similarly, what is the IUPAC name of the another structure? I wrote one more structure here beside.
Propanol.
Propanone. Which propanone? One propanone or two propanone or three propanone?
Two, sir.
Two propanone one. So second one is the example of here two propanone. So because of ketone functional group is present at second carbon atom. So that's why we can write as a two propanone. Okay. Now if you see these two structure, these two are having same molecular formula only. Okay, if you want to check it out, you can check it out in both the cases. Number of carbon atoms are, so we have a 3 carbon atoms and 6 hydrogen atoms and it has only 1 oxygen. So both are having same molecular formula but differ in their functional group. Okay, so first one is having the aldehyde functional group, second one is having the ketone functional group. So the compounds which are having same molecular formula but differ in their functional groups means that two compounds are we can call as a functional isomers. And another example, alcohols. Alcohols. So what is the general formula first? So I'll write the general formula of the alcohols. Which one means here? Ethanol. Ethanol means we can write as a C2H6O also we can write the ethanol. If you write clearly means we can write as a CH3 bond CH2 bond OH. The number of carbon atoms, number of hydrogens also we can check it out here. So number of carbon, we have a 2 carbon atoms and we have a 6 hydrogens and 1 oxygen atom. Okay, so now the given one is called as a ethanol. Ethanol. Okay, and this also we can write CH3 bond O bond CH3. So what is the functional group present in a given compound?
Alcohol.
No, here second structure. First one is alcohol. Second structure ROR. ROR. What is meant by the ROR? What it represents the ROR from ROR?
Ether.
No, ma. ROR is represent correct only ether. Ma. Ether, correct only. It represents as a ether. Okay. Now, alcohols are converted into the ethers. Both are having same molecular formula but differ in their functional group. Okay. So, alcohols are converted into the ether. Similarly, one more example. So, amines also we can consider it as a functional isomers. Amines also. Which amines means here? Primary amine, sir. Secondary amine, okay, and tertiary amine. So tertiary amine or we can consider it as a functional isomers. Okay, so primary amine, secondary amine, tertiary amines are we can consider as a functional isomers. All these are the examples of your functional isomers. Now you got the clarity, sir. Shall we go for the next isomerism? All of you. Is that clear, everyone? Say yes or no. Is that clear? Then I'll go for the next one. Good, quiet. Six members. For the six members, Anjan also you log in. Very good. Anjan, Aditi, Sangeeta, Sriveda, Sai Akshit. Right, sir. Now, next metamerism. Metamerism. So, what is meant by the metamerism? So, what is meant by the metamerism means here compounds are having same molecular formula. Compounds are having same molecular formula, same molecular formula, same functional group, same functional group, but differ in the carbon number of carbon atoms are differ in the carbon chain length, which is attached to the same functional group, which is attached to the same functional group, attached to the same functional group, same functional group. So we can show here which are they exhibit as a metamerism means here ketones also they exhibit as a metamerism and esters also they exhibit as a metamerism. Okay, so which one are they exhibit as a metamerism means here ketones. Okay, example is here ketones are they exhibit as a metamerism. Okay, and esters also they exhibit as a metamerism and ethers also they exhibit as a metamerism. Ethers also they exhibit as a metamerism. So how they'll exhibit and what are the examples means? For example, if I'm taking as a CH2 bond, CH2 bond, C double bond O bond, CH2 bond, CH2. Sorry, CH3, this one, last one is here, CH3. And I'm writing one more example, sir. What is another example means I'm writing as a CH3 bond, C double bond O bond CH2 bond CH2 bond CH3. Okay, so you can observe these two structures, sir. Both are having same molecular formula, different molecular form, different formula. So total number of carbon atoms you can calculate. Total number of carbon atoms are we are having 5 in both the structures, and number of hydrogens are so 10 are there, and number of oxygens we are having only 1. Okay, both are having same molecular formula, and functional group also same only. In the first structure also you are having same ketone functional group. Second structure also you are having the ketone function. What's the difference you are observing in these two structures? What's the difference? So let us see, sir. Here, left side, how many carbon atoms are there in a first structure?
2.
2 ma. In right side, how many carbon atoms are there in a given structure?
2.
2 ma. Okay, same. Once you check out here. So ketone functional group only. Left side, how many carbon atoms are there?
1.
And right side?
3.
3. So what's the difference it is there means here? Both are here. Then carbon chain length which is attached to the same functional carbon chain length is difference it is there. Okay, in these two structures, carbon chain length is different, which is attached to the same functional group. Hence, these two are we considered as a metamers. These two are we considered as a metamers. I'll give one more example. Okay, so another example. If you take, sorry. So is these two examples are okay. These two examples are we considered as a metamers, positional isomers, or functional isomers, and chain isomers. Is the two examples are we can consider as a metamers, or positional isomers, or functional isomers, or chain isomers? What is the correct answer?
Metamers.
Metamers. So Siveta, have you telling that these two are the examples of the metamers?
Yes, sir.
How we can explain, ma? How we can explain that these two are the examples of the metamers?
Because the position of COO है.
Position of the COO, we won't consider the position of the COO here. Okay, so here COO always be first carbon atom only. In this one also we can give the first reactive only. In this one also we can give as a first reactive only. But the thing is, the alkyl group which is attached to the ester. Okay, here CH3 is there. If you see left hand side, we have a 3 carbon atoms. Right hand side we have only 1 carbon atom. In the second structure, this is the ester functional group. Functional group is here, ester only. What are the functional group they had given as here? That is the ester functional group only. But right side, left side, if you check it out, which number of carbon atoms. So this side we also we are having 2 carbon atoms. This side also we are having 2 carbon atoms in a carbon chain length. Okay, but if you see the first one means number of carbon atoms are different. It is there in the chain length which is attached to the same functional group. Due to that reason only these two are we considered as a metamers. And one more example I'll give. Okay, what is another example means here? CH3 bond, CH2 bond, O bond, CH2 bond, CH3. Another one, CH3 bond, here CH2 bond, CH2 bond, CH3. So these two also we can consider as a metamers. So one is called as a diethyl ether. Common name how we can write means here. So this we can write as a diethyl ether. Sir, how you are telling that it is a diethyl ether means here both side we have an ethyl group only. Both side we have a left side and right side it contains the equal number of carbon atoms. So due to that reason only I wrote as a diethyl ether. Diethyl ether is the common name. Now, if we see the second structure, so right hand side we have a 3 carbon atoms, and left hand side we have a 1 carbon atom only. Okay, so how we can write the name means methyl propyl ether, methyl propyl ether, methyl propyl ether. Name only tells. Okay, name only tells about here. These two are the examples of here metamers. So because of number of carbon atoms are different, it is that here. Okay, if the number of carbon atoms are different, which are attached to the same functional grouping, that we consider as a metamers. Is that clear, everyone?
Yes, sir.
Okay, right, ma. So next. So what is the next isomerism we are having means here? Tautomerism. 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 Okay, so this one is very important for the JEE and advanced level. Okay, so tautomerism. So what is meant by the tautomerism and at all means here? So two compounds are there. The two compounds are easily interconvertible. Two compounds are easily interconvertible from one form to another form. Okay, two compounds are easily interconvertible from one form to another form. Now, one second, one. Sorry, ma. Sorry, some merchant call was there. That's why I left it. Okay, sorry, all. So here. So tautomerism. What is meant by the tautomerism means here? Two compounds are easily interconvertible. One compound is easily interconvertible to the another compound by existing dynamic equilibrium is called as a tautomerism. Okay. So tautomerism also we can call as a keto-enol tautomerism. So okay. So keto-enol tautomerism. Keto-enol tautomerism. Okay, so here tautomerism also we can call as a keto-enol tautomerism. Okay, sir, ketone means, let us see. Here first I'm writing as a CH3 bond, C double bond O bond CH3. Is that clear? So either the given compound is ketone or aldehyde mark. Is the given compound is ketone or aldehyde? What is the name of the given compound? No one is responding today. Everyone, I think so. They become as a dull. What happened? They become so tired. All are become tired. Anjan.
Is it ketone?
Ah, sir. So, what is the name of this one? What is the name of that one, sir? So, propanone, sir. So, this we can call as a propanone. Okay. So, what is the name of this one? Means with propanone. Which propanone means 2-propanone. This we can call as here 2-propanone. Okay, sir, let us see. So equilibrium. How we can express the equilibrium, sir? How we can explain the equilibrium? How we can represent the equilibrium? Equilibrium can be represented with two oppositely directed half-headed arrow marks. Okay, equilibrium can be represented with two half-headed arrow marks is called as equilibrium. Now let us see. Sir, I'm telling that keto tautomerism also we can convert we can call as a keto enol tautomerism. Why we are calling as a keto enol tautomerism means ketone group is converted into the enol formation. Sir, in name only it is there. E is represent. E is represents which one, sir? Double bond or single bond or triple bond? Samhita, E is represent as a double bond or a single bond or triple bond?
Double bond, sir.
Double bond. Okay. And Sriveda. So OL is represents which one?
Alcohol.
Very good. Alcoholic functional group. So let us see, sir. Sir, how the ketone is converted into the unsaturated alcohol means at these carbon atom. This is the functional group. Functional group adjacent carbons are we can call as a alpha carbon atom. Functional group adjacent carbons are we can call as a alpha carbons. Alpha carbons are containing the three hydrogen atoms. The three hydrogens are we can call as alpha hydrogens. So to make you understand, I'm writing like this. CH2 bond H I'm writing. Okay. So is it okay? Is anything or changes are there? Or molecular formula is correct only? Okay. So to make you understand, CH3 I wrote as CH2 and hydrogen. Okay. Now let us see how it is converted to the enol formation means. In between the carbon and oxygen, we have a double bond. In that one is the sigma bond, another one is called as a pi bond. When the pi bond is shifted in this direction, in between the carbon, hydrogen is going to be attached to the oxygen. Okay, hydrogen is going to be attached to the oxygen. Okay, so when the hydrogen is going to be attached to the oxygen means ketone functional group is converted into the OH group and double bond is present between two carbon atoms. Okay, so whenever double bond is present in between two carbon atoms means that it is converted into the enol formation only. Na? Okay, so hence, so due to that reason only we can call as a tautomerism also we can call as a keto-enol tautomerism. Okay, so keto-enol tautomerism. And this is also we can call as desmotropism. This also we can call as here desmotropism. Sir, what is meant by the desmotropism? Desmotropism is the Greek word. In this one, desmo means pi bond. Okay, that means here desmo means bond. Troposma. Tropos. So tropos is nothing but turn. Okay, so tropos is nothing but here turn. So now in the given structure, pi bond is going to be shifting or it's not shifting here in above structure. In above structure, if the pi bond is shifting or not shifting. Pi bond is shifting now. So pi bond is shifting from one place to another place. Okay, so when the pi bond is shifting from one place to another place, that is only we can call as a desmotropism. Okay, so now you got the clarity, sir. What is meant by the tautomerism means here, sir? Tautomerism is nothing but so two compounds are having same molecular formula. One compound is easily interconvertible to the another compound by existing dynamic equilibrium is called as a tautomerism. Okay, shall we see some examples? Which one is exhibited as a tautomerism or not? Okay, right, sir. Sir, here also we can explain the stability. First, I'll explain the stability. So, in this two ketone and enol formation, which one is more stable means ketone formation is more stable. Okay, so ketone formation is more stable than enol formation. So ketone is more stable than that of the enol formation. Sir, here also one exception case is there. Some cases, enol formation is more stable than ketone. More stable than ketone. Okay, sir, what is the example for that one means here? CH3 bond, C double bond O bond, CH2 bond, C double bond O bond, CH3. Okay. Now let us see ma. Here, if you see means beside the ketone group, how many alpha carbon atoms are there? Total number of alpha carbon atoms present in a given molecule.
5.
No. I'm asking only alpha. I'm not asking total number of carbon atoms. I'm asking only alpha carbon atoms.
2.
Two only. Yeah. Anjan, how many alpha? How many alpha carbons, Anjan?
One, sir.
Aditi, this is the number of alpha carbon atoms present in a given molecule.
3.
Very good. Very good, Samhita. Okay, so three alpha hydrogens. So now only I told that adjacent, let's see above structure. Adjacent functional groups carbon atoms are we can call as a alpha carbon atom. That means this is the ketone functional group. So this side also one carbon is there, this side also one carbon atom it is there. Okay, and if it is a ketone functional group means this side one and this side one. Okay, the total number of alpha carbon atoms are given molecule is equal to 3. How many alpha carbon atoms are there means here 3 alpha carbon atoms are there. In that one, which carbon is more reactive? That means which hydrogen is more reactive to involves in a tautomerism means here this carbon atom here. Okay, that carbon atom. So last time I told that secondary carbon, so tertiary, secondary, primary it will be there. Sir, which are more reactive means tertiary is more reactive. After that secondary. Okay, I'll write here. Which hydrogens are more reactive means here tertiary hydrogen is more reactive than secondary. Secondary is more reactive than primary. Okay, so now you got the clarity, sir. So which hydrogen is more reactive means here tertiary is more reactive than secondary. Secondary is more reactive than primary. So this one is more reactive. This hydrogen is involved in the tautomerism. Okay, so which hydrogen, sir? Sir, secondary hydrogen is involved in a tautomerism. Now let's see. When these hydrogens involved in a tautomerism means, sir, double bond is formed in between these two carbon atoms only, na? All of you are you able to see the structure? Okay. Now I am writing, sir. So from here I am transferring the proton to this oxygen atom, and the double bond is shifted in between these two carbon atoms. Then you will get as a CH3 bond, C double bond O bond, C H bond. Sorry, here not double bond now. It is converted into the enol formation. Right, sir. OH, C double bond O bond CH3. Sir, here also enol formation only. Here also enol formation only, na? Then how it becomes as a more stable? How it becomes as a more stable means due to the formation of the intramolecular hydrogen bond. Okay, so due to the presence of intramolecular hydrogen bond. Intramolecular hydrogen bond. Sir, first of all, what is with the hydrogen bond, sir? Aditi? Madhusudan? I think so. Aditi, let me not check it out. Aditi. Aditi, what is mean by the hydrogen bond? Aditi is not responding. What happened to Aditi? Next. Sriveda,
Yes, sir.
what is mean by the hydrogen bond?
Bond between hydrogen and hydrogen.
Bond between hydrogen and Sriveda, I didn't listen clearly. Samhita,
Yes, sir.
What is meant by the hydrogen bond, ma? What is mean by hydrogen bond?
Don't know, sir.
Don't know. Anjan?
Hydrogen bond is like covalent. It's not covalent, but uh, it is bonding to the.
It's a simple example I'm telling you. Sir, I'll explain here. What is meant by the hydrogen bond means? Sir, actually we have a different types of the bonds. One is ionic bond is there, covalent bond is there, okay, and coordination covalent bond is there. Is that clear? Okay. In that one, ionic bond is formed by the electrostatic attraction forces. That means the attraction forces which are present in between two oppositely charged ions. That attraction forces only we can call as a ionic bond. And covalent bond is formed by mutual sharing of electrons, give and take policy. Okay. And coordination covalent bond is formed by sharing of lone pair of electrons between two atoms is called as a coordination covalent bond. So then what is meant by the hydrogen bond means? So hydrogen bond is nothing but the weak electrostatic attraction forces are present in between positively charged hydrogen atom and highly electronegative atom. Okay, sir, what are the electronegative atoms we are taking in the formation of the hydrogen bonds? Means we are taking only nitrogen, oxygen, fluorine. Other than these three, we are not considering any other atoms. So, what are the atoms we are going to consider in the formation of the hydrogen bond? Ma? We are considering only nitrogen, oxygen, and fluorine. Okay, so what is the hydrogen bond means? The electrostatic attraction forces are present in between positively charged hydrogen, highly electronegative atoms is called as a hydrogen bond. And there is also we have two types of the hydrogen bonds. One is intramolecular hydrogen bonding, intermolecular hydrogen bonding. Okay, intramolecular hydrogen bonding means if the hydrogen bond is present within a molecule, if the hydrogen bond is present within a molecule is called as an intramolecular hydrogen bond. Okay, what is meant by the intermolecular hydrogen bond means here? If the hydrogen bond is present in between two different molecules, okay, two different molecules means let's see. First one I wrote as intramolecular hydrogen bond. And what is the intermolecular hydrogen bonding means? I'm taking as a 2 moles of the hydrogen fluoride. Okay, so two hydrogen fluoride molecules are there. The bond which is present between the fluorine and hydrogen is called as a intermolecular. That means if the number of molecules are increases, number of hydrogen bonds are going to be increases. This we can call as a inter. This we can call as a intra. Intra means within a molecule. Okay, so what is the effect of the intramolecular hydrogen bonding means due to the presence of the intramolecular hydrogen bonding, it forms as a cyclic ring. If you see clearly, Mima, it look like as a cyclic ring only, na? It look like a cyclic ring or not? Anjan, after formation of the hydrogen bond, the given molecule is, it look like as a cyclic ring or not?
Yes, sir.
Okay, so formation of the cyclic ring is called as a chelation. If the cyclic ring C is going to be formed, means it increases the stability. Okay, it increases the stability. So due to that reason only, enol formation is more stable than that of the ketone. Is that clear, everyone? Okay, sir, based on this one, tomorrow we are going to discuss some of the questions. Okay. Is that clear? So better all of you once you read the atomerism until the atomerism and please come now. We'll discuss in the next class. Finish? So we'll continue in the next class.
Yes, sir.
Okay? Right.